In this video, let us see Stokes theorem. Stokes theorem gives you the relation between line integral and the surface integral. Okay, so let us see the statement of Stokes theorem here. The statement is, if S is an open surface bounded by a simple closed curve C and F is a vector point function having continuous partial derivatives, then integral over C f dot dr is equal to double integral over S curl f dot n ds, and moreover here it is closed curve, so we can represent the integral over C as a closed curve. So this is what the statement of Stokes theorem, and where n cap is the unit outward normal to the surface and always C is taken in the anticlockwise direction. So here let us see one problem. The question is, verify Stokes theorem for f vector. The given f vector is this: over the surface of a cube bounded by x equal to 0, y equal to 0, z equal to 0, x equal to 2, y is equal to 2, z equal to 2 above the xy plane. So here it is already given that it is cube. So cube means all the dimensions are same. That is length, breadth and then height all are same, and here it is given to be 2. Okay, and then here we have to consider the cube above the xy plane. What do you mean by above the xy plane here? Cube means it consists of it is like a square box, right? So if you consider a square box, how many surfaces will be there? There will be 6 surfaces. Since here we are dealing with the Stokes theorem, it is nothing but open surface. S is open surface. So that here we are considering the cube above the xy plane. That was mentioned here because of here we are verifying the Stokes theorem. So above the xy plane is nothing but we have to consider only the 5 surface, and we have to omit the surface which is exactly on the xy plane. So out of 6 surface, we have to consider the remaining 5 surfaces, and the surface on the xy plane will be kept open, and that will considered as a square, and that square is considered as the closed curve C here. Okay. So for this vector f, we have to verify the Stokes theorem. That is, we have to verify LHS is equal to RHS. That is, left hand side should be equal to the right hand side part. So we have to evaluate LHS part separately, RHS part separately, and then we have to prove both are same. Now let us see the diagram here. So this is the cube. Okay, we have to construct a cube like this. By the corresponding 3 axes we have taken like this: x axis, y axis and z axis. Actually this is z axis, right? Now we have to plot the coordinate points. So this is always taken as the origin 0 0 0, and then here A is on the x axis, so y and z will be 0, and since the cube is considered with the dimension 2, we have to consider the coordinate points as 2, 0, 0. Similarly, for the point C, it should be 0, 2, 0. Similarly, for G, it should be 0, 0, 2, because all are lying on the particular axis. Apart from that, if you notice B is in the xy plane where z equal to 0, so the coordinate point should be 2, 2, 0. Similarly, for F, it should be what? 0, 2, 2. And then for D, it should be 2, 0, 2. Apart from that, E, the point E is nothing but it will be in the space at a distance of 2, 2, 2 from x, y and z axis. So likewise, first we have to plot the coordinate points. So based on this, we have to do the problem, right? So here, before that, we can represent the unit vector I here for x-axis, j for y-axis, and what is this, k for z-axis, right? And then here, we have to consider the cube above the xy plane. So what is xy plane? This is xy plane. So here this bottom surface is kept opened. So the remaining are considered as 5 different surfaces. That is front part, back side, left, right and then top. So we have to consider all these 5 surfaces except the bottom. So bottom, since it is kept open, the curve will be in the form of a square. Okay. So we have to consider the direction like this in anti-clockwise direction, and this is the curve C, closed curve C. So this will be helpful while evaluating the left hand side part, line integral over C f dot dr, right? And then for remaining 5 surfaces, we have to evaluate double integral S curl f dot n ds, right? First, let us evaluate the left hand side part, that is line integral f dot dr. So now first let us evaluate the left hand side part, integral over C f dot dr. So for that we have to consider the closed curve C. Okay, so we have considered only that square portion alone. So this is the square portion lying on the xy plane, right? So that here, since we are considering the xy plane, z-axis is equal to 0. So what we can consider here is, let us consider z equal to 0. So when z equal to 0, dz is equal to 0, right? So why we are considering this? Because here we have to calculate f dot dr. F vector is given here, this is plus. Okay, so f vector is given already here. We have to calculate f dot dr. So f dot dr means what? Actually dr is equal to dxi plus dyj plus dzk. So while taking dot product with this f, we will be having y minus z plus 2 into dx, yz plus 4 into dy minus xz into dz. So anyway, dz is equal to 0 here. So while substituting z equal to 0 and dz is equal to 0 in this f dot dr, it will be reduced like this. Okay. So this is because of the xy plane. Okay, in xy plane, because the curve C is in the xy plane. So now here we have to calculate the line integral, that is integral f dot dr, and this integral over C is nothing but a combination of OA plus AB plus BO plus CO again. Okay, so we have to start from O, travel along these 4 lines, and then we have to again reach O. So it will be a closed square, okay, curve. So along these 4 different straight lines, we have to calculate what is the line integral f dot dr. So first let us consider the terms here. So if you consider the line OA, that is along OA, here OA is nothing but it is exactly the x-axis where y is equal to 0. So here we have mentioned it as y is equal to 0, which means that dy is also 0, right? And what about f dot dr in this case? This is already f dot dr. Here if we have to put y equal to 0 and dy equal to 0. So if you put y is equal to 0, here you will be having 2 dx and dy is also 0. So final answer is 2 dx. And while evaluating, so in terms of, in place of f dot dr, that is this is equal to that is integral over c f dot dr is equal to integral along OA, integral along OA f dot dr. So along OA, what is f dot dr? It is 2 dx plus integral along AB. So integral along AB is nothing but x is equal to 2, right? So why it is x is equal to 2 here? Y-axis means x equal to 0. X-axis means y is equal to 0. And this AB is the line parallel to y-axis, means it will be the line x equal to a in general. Here since the dimension is cube, the dimension is 2. So here this line represents AB is the line x equal to 2. Similarly, BC is the line y is equal to 2. So if we represent like this, it will be easy for calculation. So now along the line AB, that is exactly the line AB itself, x is equal to 2. Since x is equal to 2, dx is equal to 0. And hence f dot dr will be, since dx is equal to 0, this term becomes 0, and then we are left with 4 dy. So 4 dy. And if you see the limit y varies from 0 to 2, because here the derivative is y. We want the limit for y here. So y means for the line AB, where it starts from y is equal to 0 to y is equal to 2. So we can mention the limit varies from 0 to 2. Similarly, for the line OA is also the same. For OA, it is from x equal to 0 to x equal to 2. See the direction from O to A. So x varies from 0 to 2. For A to B, y varies from 0 to 2. Likewise, along BC, what it is? BC is the line y is equal to 2. So dy is equal to 0. So if we substitute here f dot dr is equal to 4 dx, in such case, x limit we want. So for BC, x limit is 2 to 0. So that here we have mentioned 2 to 0. Similarly, along CO also. Along CO, x equal to 0. So dx is equal to 0 here. So that f dot dr is 4 dy and y limit is from 2 to 0. Right? So based on this, here we can add all these things. That is along OA plus along AB f dot dr is 4 dy plus along BC it is 4 dx plus along CO it is 4 dy, right? So now what we have to do here is instead of OA, AB, BC and CO, we can apply the respective limits here. So what are the limits for the first line OA? It is 0 to 2. Next 0 to 2. Here it is 2 to 0. Again 2 to 0. Right? Now we have to integrate it. While integrating it, it is 2x 0 to 2 plus 4 into y 0 to 2 plus 4 into x 2 to 0 plus 4 into y 0 to, sorry, this is also 2 to 0, right? 2 to 0, 2 to 0. So what will be the answer here is, we have to evaluate it. So here 2 into 2, 4, upper limit minus lower limit. So anyway, one of the limit is 0 here. So we can apply the limit 2 alone. So upper limit is 2 here. So 2 into 2, 4. So this is equal to 4. This is 8. And here it is minus 8. That is upper limit is 0 minus lower limit is 2. So 2 into 4 is 8 minus 8. Again here also minus 8. So what happens here? Plus 8 and minus 8 get cancel. So this is equal to minus 4. So LHS is minus 4. Right? That is integral over C f dot dr is minus 4 here. So similarly, we have to prove the right hand side part is also minus 4.
Now let us calculate the right hand side part. So right hand side is curl f dot n ds. For that we have to first find out curl f. So what is curl f? Curl f is nothing but del cross f, right? So now let us calculate what is del cross f. Del cross f is nothing but determinant of I, j, k taken as a first row. Second row is dou by dou x, dou by dou y, dou by dou z, and the component we have to consider from the question, y minus z plus 2 and then yz plus 4 and then minus xz. So these are the elements. Okay, so now we have to take determinant here. So while expanding this determinant, we used to get the answer as minus yi plus z minus 1 j minus k. That is, if we take I component, we have to omit that first row and column. So dou by dou y of this is 0 minus dou by dou z of this term will be y. So minus yi. Similarly, we have to do the remaining thing. So finally, del cross f vector is minus yi plus z minus 1j minus k. Now using this, we are going to find out the double integral over S for this curl f dot n ds for all the 5 surfaces, because here double integral over S curl f dot n ds is splitted into double integral over surface S1 plus S2 plus S3 plus S4 plus S5. So what are these surface represents? That is surface S1 we can take it as DABE, that is front part of the cube. Similarly back side we can take it as S2. Similarly right side we can take it as S3. Left side we can take it as S4 and top we can take it as S5. So we won't be considering the bottom portion since the surface is an open surface. Now we have to evaluate all the 5 double integration and then we have to add it together. Now if you notice, already del cross f we have found out, that is curl f minus yi plus z minus 1j minus k. Now according to this cube, we can consider the surface S1 as the front portion of the cube, that is DABE. Similarly S2 will be back portion, that is GOCF. Okay, so this is F actually, this is F. And then next S3 will be the right hand side surface, that is EBCF. And then S4 will be the left side portion, that is DAOG. Okay, and then top portion is GDEF. So all these 5 surfaces we have to consider. Apart from that, here we have mentioned x is equal to 2 for surface S1. Why we have represented x is equal to 2? If you see the front portion of the surface of the cube, it is parallel to the YZ plane. Right, it is parallel to the backside surface. Backside surface is exactly on the YZ plane, but front portion is parallel to that. At which distance? At x is equal to 2. Actually this point is what? 2 comma 0 comma 0. So this this surface is at a distance x is equal to 2, right? So that here we have mentioned x is equal to 2, that is it is parallel to what, y z plane. So y and z are 0 here, that is the thing. Okay, similarly GOCF, the backside surface is exactly on the YZ plane where x is equal to 0. Right, similarly S3 is the right hand side surface which is exactly at a distance 2, so that we are taking y is equal to 2. Similarly the surface DAOG, that is S4, exactly lies in the xz plane, so that y is equal to 0 here. Similarly the surface top surface is at z equal to 2. Okay, so like this we have to specify this. And what about the corresponding unit outward normal? Suppose if you consider the surface S1, for x-axis the unit vector is I cap. Okay, so this will be the unit outward normal, that is this is facing outward from the surface, goes outward from the surface, so that for this surface it should be I cap, so that here we have written I. Okay, similarly what about the surface S2? S2, that I will be going towards that side. Okay, so it will be minus I, so that here we have mentioned minus I. Similarly for right side surface it is J, for left side surface it will be minus j, right? Similarly for k, for the top surface it will be k. There is no bottom surface, we won't be considering the bottom surface, so we will be having only 5 surfaces. So this is n cap. What about ds here? So ds is nothing but the surface where we are taking the surface. For example, if you consider the surface what DABE, that is parallel to the YZ plane, which means that if you consider the projection that falls in the YZ plane where x is equal to 0, and then we have to consider the integration with respect to y and z, that is we are going to consider the double integration for that region. Okay, so where it lies means it lies in the yz plane, so that we have to consider the derivative as dy dz here. That is actually the formula for ds is dy dz divided by modulus of n dot I. Right, already n cap is nothing but I, so that I dot I is equal to 1, so that we are getting it as dy dz in case of yz plane. That is the thing happens for this surface S2, right? For the surface S2, I will be minus 1. So anyway, here we are taking modulus, right? So minus I into I dot I will become minus 1. So modulus of minus 1 is plus 1 again. So that here we are writing dy dz. Similarly, for S3, what happened here is S3 means it is parallel to the xz plane, right? In such case, for xz plane here it will be dx, it should be dx, okay, divided by I dot j. So here n cap is equal to j means j dot j is 1, n cap is equal to minus j means minus j dot minus j, right? So that after simplification we'll be getting dx dy, right? This is similarly this way we have to write it for surface S5. Surface S5 it will be dx dy derivative, right? So after making a table like this, actually what we have to do is we have to calculate a double integral over S, curl f dot n ds. This is what we have to calculate, right? So here for that we want to find out what is curl f dot n, that is del cross f dot n. So already we have found out del cross f is this, n cap is given here, take the dot product of these two. So I with I means y minus I dot f, where del cross f is nothing but minus into minus plus, so plus y. Similarly, for surface 3 it is z minus 1, for surface S4 it is minus of z minus 1, and for surface S5 it is minus 1. So likewise we have to consider the dot product of del cross f dot n by using this table and the vector del cross f. After calculating this, now we have to evaluate the double integral. So double integral S curl f dot n ds is equal to double integral curl f dot n for surface S1 is minus y dy dz. Derivative ds is dy dz. For surface S1, what are the limits for y and z? Here throughout for all the surface integral, we have to consider the limit as 0 to 2 for x as well as for y and z, okay, because the dimension of the cube is 2, so that we can straight away take the limit as 0 to 2. So here direction is not needed here while evaluating the surface integral, okay. So this is for surface S1. Plus what about surface S2? Again 0 to 2, 0 to 2 plus y dy dz plus double integral 0 to 2, 0 to 2 z minus 1 into derivative is dx dz. Like this we have to proceed. So plus for the next surface, that is S4, it is minus of z minus 1 into dx dz plus double integral 0 to 2, 0 to 2 minus 1 into dx dy. So now we have to integrate it. So now evaluating it, here it is minus y square by 2, 0 to 2 dz. We are left with the dz, right? Similarly, integral 0 to 2 y square by 2 dz plus integral 0 to 2 z minus 1 into x 0 to 2 dz plus, or we can write minus integral 0 to 2 z minus 1 x dz. Last is integral 0 to 2 x and then dy, right? So now we have to apply the limit here. So this is equal to minus 4 by 2 is 2 again, and then now we are left with the integral dz. So z 0 to 2 again here, plus 2 into z 0 to 2, and then here it is 2 into z square by 2 minus z 0 to 2. Similarly here minus 2 into, and then minus 2 into y 0 to 2, right? Now applying the limit here again, this becomes minus 4, this becomes plus 4, and here it is what, 2 minus 2 0, right? So plus 0 minus 0, and then here minus 4 again. So this minus 4 and plus 4 get cancelled, and then here the answer is minus 4. So finally what we have evaluated here is right hand side is equal to minus 4. Already we have calculated the left hand side also minus 4, and hence what, LHS is equal to RHS. Okay.